So just power cycle that one.
Okay.
Okay, so everything should be power cycled. And within about,
Yeah.
so within about 60
Oh,
seconds. Hang on 1 second.
man.
I'm in a Zoom.
I will admit a mistake.
Okay, I'm back. Thanks. Thanks for bearing with me, guys. All right, can you guys all hear me? All right, sorry about yesterday. I was working yesterday on several things, some to do with the class and some to do with other things. So I felt I would just do the physical layer offline or asynchronously. So by the way, I sent out, because I was driving on the way here, I ran into a little bit of traffic because where I drive through goes by where George Floyd's funeral was, and so there was a lot of traffic in that area. So I posted on Facebook how many people I had there. If in case you didn't know this, there is a Facebook page for this class, MIS 4477. I also have a Twitter account, so I should probably start using that. Do you guys do more Twitter than Facebook, I'm going to assume? Got a couple of more Facebook. So some of you do Facebook, some of you do Twitter. I was trying to think of the best way to communicate and the easiest way to communicate, especially when I'm driving or I'm away from a computer. So I think I'll try to get myself into the habit. I need to download the Twitter account onto my phone. I got a new phone, so I need to put it on there. And I'll make a habit if this comes up again where I'm going to be late or postponing something, that I'll tweet that out. Okay, so like I said, the physical layer and it's probably less important, to tell you the truth, to have that one synchronously where you can ask questions on it. And you can certainly email me later, but the physical layer, like the application layer, is probably more easy for most people to understand, because the physical layer is what you guys are actually communicating with, or well, you're touching it, feeling it. The application layer is what you use to get your thoughts into the network model, and the physical layer is what's used to get your physical movement into the network layer, in and out, your keystrokes and your voice and your video and whatever it is. That's how we physically interact. So humans are pretty familiar with the top and the bottom layers, layer 5 being application, layer 1 being physical. Least understood of the layers, in my opinion, is the data link layer, which is layer 2, which is a pretty critical layer to understand. And now, as network managers and business type people, you probably won't have the need to fully understand all of the aspects of a data link layer, layer 2, but you do need to have a good background as to why a data link layer is needed and why it exists, as opposed to just going from physical layer to network layer, which is where all of our IP addresses are, and then up application layer. Why do we need this data link layer? So let's do this. Before I talk about the data link layer, and I'm going to bring up the PowerPoint presentation, I was in the process of attempting to upgrade the virtual machine template that I use, and I'll share my screen in just a minute here. Upgrade that to Windows 10, mostly for the 4397 class that I teach, but I think it's probably important to go ahead and upgrade those, because what I do is I provide a Windows 7 virtual machine. Everybody's going away from Windows 7. It's been sunsetted or end of life. That Microsoft calls it end of life. Sometimes they call it sunsetting. And so I probably should be teaching you guys more current, on more current platforms. So give me one sec here to share a screen, and we'll see where it's at. I started it before I left the house, started some work, and we'll see where it's at. Okay, so let me pull up my browser and drag it over to the other screen first. Then I'll share it. Move some things around here. So as I mentioned before, using Chrome Remote Desktop, very powerful stuff. I've put the Chrome Remote Desktop on all of the servers that we use in the EI lab, so that I can do various different things with it at different steps. So let me share my screen 2 here. And we're going to look at a few different virtual machine, mostly servers, that are in the lab. The ones that have UH in front of them are typically the ones that's what I do to rename them or indicate that these are what's here at the University of Houston. Anything else you can just ignore. They're either my personal machines or machines, excuse me, machines that belong to some of my other clients or some of my other businesses. Pull out the chat window here. Okay, so first of all, this happens to be a virtual machine which is running under VMware. It doesn't necessarily matter what it's running under, but you guys are gonna get something similar to this machine. And the way I'm accessing it right now is through Chrome Remote Desktop. I'm gonna use this keyboard.
Wrong number.
See what's on the screen. I might have to hide some stuff real quick now. Okay, nothing that important. That's super important.
Yeah. I want to
Somebody's talking. Excuse me. Okay. So this is what you're going to get, a virtual machine. So let's just look at some of the details of this virtual machine. And again, this is Windows 7. Like I said, I'm going to try to provide you guys Windows 10. Now, for those of you that aren't Windows people, I'm assuming everybody in here has at least used a Windows machine before. But so I'm just going to point out some differences between Windows 7 and Windows 10, because these are things that you're going to be needing to look at often. Instead of computer, it's called this PC in Windows 10. But if you click on whatever button is in the lower right-hand corner here, unless you've moved it around, you know, you can customize these things because you have admin access. But I don't recommend going too far away from the customization. You right-click on computer and go to properties. In the case of Windows 10, you right-click on this PC. It says this PC on the menu. And you go to properties. You see these properties here under the computer name and domain. These are things that you probably want to pay attention to. So this says it's Windows 7. You don't want to change these things. I'm only pointing these out to you because these are things that you may need to make note of, or if I tell you, if you're having some issue and I tell you, let's go try to change those things. So this computer name happens to be Jake-Win764. Your virtual machine that I'm creating is going to be called something like student VM-some number. And this will make sense in a minute when I show you how I'm going to build. We're going to do that. I'll walk you through how I build the catalogs. I need to bring up my instructions. Give me a second. Move my chat window over. Remote viewing another computer that I have where I have the instructions up on it, because there's about 15 or 20 different steps that I do. One sec for me. I got a whole building in downtown Houston without internet. Okay. Pardon me for this. Got my instructions up. Okay. So next thing I'm going to show you is I'm going to go back to my remote desktop or open another remote desktop screen. There's that little icon there. And it is the domain controller. Now this is just a generic domain controller. This is a Windows Server 2012. Now let's see, I'm going to drag it off my shared screen just in case I have user accounts up. I don't want, I think I've deleted them all, but I don't want you guys to see user accounts. No, actually, I'm pretty sure I don't have them on there. Sorry about that. I put my phone on vibrate. And let's see where we're at on here. Now that might be kind of small. Okay, so probably a lot of you are not that familiar with domain controllers and how Windows chooses to manage a network. But one of the items, one of the elements underneath Windows Domain Controller is called Active Directory Users and Computers. I'm using a package, an application that comes with Windows called Active Directory. And go ahead and close that. So first thing you'll notice about Windows servers, and this is pretty much only unique to Windows servers, not to Hyper-V, not to Proxmox, KVM, other virtual environments or domain controllers in general, is their machines can work like workstations. So this DC1, UHDC1 here, is a workstation and a server at the same time. I've got Chrome installed on it, and I can use it to do workstation work, but I probably don't want to because I would slow things down. Most of the server environments that I set up, the server console screen, which is what we're looking at right now, doesn't look anything like this at all. Typically, it is a text-based only console screen with a menu on it, with various things that you can do, but you typically don't want to do too much on your local server machine console because it'll slow everything else down. So if I look here under administrative tools, you'll see I've got several Active Directory something or others. I can go to this administrative center and see all of it, but I'm just going to go here to Active Directory users and computers. So the way Windows domains work, and first of all, you guys know what I mean when I say domain? And I'm not talking about uh.edu. That's a internet domain. A Windows domain originally was basically what they called a network or a LAN, not a wide area network, just a local area network, which is an organization of locally attached computers. Every computer has a unique name called a NetBIOS name, by the way. I pull up a WordPad document here. So you can go look up these terms. You need to know what these terms are. So NetBIOS, basically what that stands for is Network Basic Input Output System. And the NetBIOS is the code that runs on your workstation and your computer's servers, which handles the networking part. It is a combination of layer 2 and layer 3. We're gonna, like I said, we're gonna try to talk some about layer 2 today. So you can go Google for, read a little bit of wikis, get a little bit of information so that you understand, first of all, what the concept of NetBIOS is. Don't need to get too technically heavy into it. Just know where we get that name from. It refers to the code. So if I say NetBIOS name to you or to anybody, what I'm talking about is the name generally of the computer itself. So in your case, if you've got a Windows computer right now, or if you have a Mac, you can do this also. I don't know where exactly it is in the Mac, but in Control Panel, and there's several ways to find your NetBIOS or your computer name, and it has to be unique on a local network, just like an IP address needs to be unique on a local network. If it's not unique, you have conflicts. You can name two computers the same thing, and it might work, but you'll have conflicts. You should not do that. So this virtual computer I'm looking at is called, or excuse me, this virtual computer, this domain controller is called DC1. Just like my computer was called Win764. Just like this Windows computer that I'm viewing here, which is, oh, that's interesting. I just realized my computer that sits on my, oh no, I'm confused. Did not realize. I'm remote viewing a screen. Okay, property. So this PC, this is a Windows 10 computer that I'm actually talking to you on with Zoom. It's called Jake-HP8770W. Now here's a few rules, because you do need to know this, either for now or for the future. Hang on one second for me. Okay, so this one's called this. What you need to know about NetBIOS names is they do follow some rules typically, and this is so that it's downward compatible with older Windows computers like XP and Windows 7. NetBIOS names can't be more than 15 characters long. They can't have too many weird characters in them. We've got one dash in here. Dashes are okay. You probably should not mix and match upper and lower case because Windows or Microsoft does not play well with upper and lower case. Some things are case sensitive, some things are not, and that's because Microsoft tries to be backward compatible to many years ago with older computers, even back to like Windows 95 and Windows 98, when there are some computers that upper and lower case didn't matter. So they try to discourage the use of the mixture of upper and lower case letters. Now you'll notice this computer name, in my case, is made up of the full computer name. And that's another term you need to know, by the way. Where's my pad? Oh, I think I opened Notepad on a local computer. Let me open it here. Pad. Or I just lost it. That's okay. FQDN. So fully qualified domain name is the full name of a computer along with the name of the network that it's on. So in this case, on my local computer here, my laptop here, I'm not on a network, or I am. I'm on a temporary LAN network. And this is going to be true for most of you. You're going to see your computer name. And by the way, another name for your computer or a name for any node on a network is host. Host name equals computer name. Okay, so keep these things in mind. Some of you might know this stuff. This might be review for some of you, but host name. Fully qualified domain name is a combination of the host name plus the domain. So when you're just on a local computer or on a laptop, it's usually made up of the name of the host and then possibly the name of a domain or a work group. So, and I know some of you have seen this with Windows. You'll see something called work group, and then you'll see something called domain. Your computer is either a member of one or the other of those. When you buy a new computer and you set it up, how many people have bought a new Windows-based computer recently? Anybody bought one and set it up recently? Maybe not actually built it, but you've turned it on. And it was probably a member of a work group called, quote unquote, work group. So your fully qualified domain name on a brand new computer is probably something like HP 12345 if it was an HP computer dot work group. So that kind of looks like a domain, internet domain name, although with internet names, we have something called TLD on the end. Or you might see HP12345.local. In the case of a domain, first of all, you have to have at least one computer on your network that chooses to be the domain controller. And what the domain controller does is it controls access. It controls the usernames and passwords. It controls what computers are allowed to share what resources on that network. So it's called a domain controller. You have to create a unique domain name for your network. So in the case of this computer, the domain is called eilab.bower.uh.edu. Didn't have to be called a name that looks like this. Ignore the DC1 for just a minute. So the domain here is eilab.bower.uh.edu. Because you have the option to name your network domain controller or name your domain the same thing as an actual internet domain if that domain is potentially accessible or shareable on the internet. So we have a domain at U of H called uh.edu. We have a domain, a sub-level domain, a subdomain within this building called Bower, because this is the Bower College of Business. And then within the EI lab here, which is where I'm sitting, room 122, this is its own subnetwork off that. So it's called the EI lab. So bottom line is all computers within this domain, all my servers, all the virtual workstations you're going to use are going to be called something dot student VM dash 45, 46, 47, something like that, dot eilab.bauer.uh.edu. Sometimes that's a dot. Most of the time it's a dot. Sometimes it's specified on 2 different lines. So the fully qualified domain name, the FQDN of this computer is DC1. You'll notice it's uppercase. The rest of the domain name is lowercase. The domain name needs to be lowercase if it's a domain that, again, can potentially be put out on the internet or accessed from the internet. Okay, so if we look at this Active Directory users and computers, this is just an application on the domain controller. Here's the domain name here, and you can have multiple domains within one physical network, but usually you just have one on a small network. If I click there, you see computers. These are the names of computers that have been added to the domain, and you can, there's multiple groups here, several groups of computers. I have 2 domain controllers, DC1 and DC2, domain controller 1 and 2. Most commercial networks are going to have at least 2. One's a backup to the other. If a domain controller goes down or can't be reachable, even though your computer, your workstation is fine, and even if it could communicate with the network, the internet, it communicates with the gateway, it's a separate device. If the domain controller is down, you usually can't do anything because it's all about the authentication. So if I can't authenticate, when I first turn on a computer, can't do anything with it. So many commercial networks have 2 domain controllers, and they periodically, every few minutes, sync up with each other and share information. Okay, we all good so far? You guys awake? I've got the video off, so I can't see if you guys are doing some creepy stuff. Hopefully not. And then I've got down here users, and this is where at one place where I would add the name of users or the names of users on a network. Let me, and here I've got another folder called workstation. Let me just blow all these things up and you see what some of them are. Now, if we look under groups here, let's take a look at groups first. I've got under groups something called master users. So these are the users that were originally set up. Danny Wynn was the guy that set up this domain a long time ago. Jimmy Cawley was one of the teachers that used to teach this class a long time ago. And then there's me. So I put myself, or we put ourselves in this group called master users. This is all stuff that domain admins can have the discretion to call it whatever they want, but we try to follow certain guidelines on this. You got something here called Zen users, and this is what I'm going to introduce to you next. There's 1 user in there right now. I'm going to add everybody else into this list by taking the rosters. I was in the process of doing this. I put them in a spreadsheet, and then I actually build a script out of your name, your student ID, and then I come up with a random password, which you guys will get in an email, that I fill into the domain controller here, and I put them under the special user group called Zen users, because then my next step, which I'm about to show you here, is we create what's called a catalog of virtual machines using something called the Zen Citrix Desktop Studio. So before I show you that, let's take a look at another virtual machine, which is actually the virtual server. And it's not a virtual server, it's a real server. We're virtually looking at it, called vCenter. This actually is a virtual machine that I'm simply using as a window to the VMware servers. I have 2 physical servers in the EI lab here that are acting as a VMware cluster, we call them. So you can go Google for and look up VMware. Make sure you know that what VMware is. It's a hypervisor, very much like Hyper-V. We learn, and we do this, and you learn about this in my 4397 class. So I recommend that you sign up for 4397. Just trying to follow up on this. Okay. EI Lab is the name of the VMware cluster that I've created, similar to domains. Within the EI Lab, we've got two servers that are running together. Actually, let me back up here. Go to inventory. Or go to home. I'm going to go to home here. So within the EI Lab, I've got two servers here. I've got esx.eilab.boweruh.edu because I've named them with domain names, and ESX2. These are two servers that are operating a virtual environment in which these desktops here live on. So this, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 virtual desktops. These are all Windows computers, Windows operating systems of different flavors that are currently living on this hardware. And the virtual environment allows me to have multiple virtual machines running. This template Windows 764 is what I use or had been using in the past. And I've already got a console window too. And this is the computer I was logging into and using earlier. Press Control-Alt-Delete here. Yes, send Control-Alt-Delete. I've talked about that, I think, already in this class, where you've got to somehow send quote-unquote Control-Alt-Delete because you can't do it on your local keyboard there. I'm logged in as this master user, Jake. Let's see what I was in the process of doing. I was probably in the process of doing all the Windows 7 updates before I started cloning it, which is what I'm going to do. I'm going to clone this template, which is a base Windows 7 computer with hardly any software on it, because you guys are going to be installing your own software on it. I could have put Chrome on it, but I want you guys to download and install Chrome and set up a Google account. So this is what you're going to end up with, is a virtual machine like this. It looks like the updates are done. So you may get this, or if I get this Windows 10 machine working, I'm going to try to get you a Windows 10 machine. Has anybody ever done an upgrade from a live Windows 7 machine to Windows 10? Not bought a new machine with Windows 10, but actually done an upgrade in place by going out and either buying a Windows 10 DVD or downloading the Windows 10, what they call the media creation tool, and actually upgrading Windows 10 to Windows 10. You can do it still. You can Google for it or go to Microsoft.com and download the Windows 10 ISO. By the way, that's another term that you probably need to get familiar with if you're not, an ISO file. Now, first of all, what is the ISO? That's important to know for other reasons. So the ISO is an organization. It stands for the International Organization of Standards. They're a standards-making body. And that's in a later chapter we're going to learn, but probably good for you to go look up who the ISO is now. International Organization of Standards. They're similar to ANSI, American National Standards Institute. They set standards for different things. They're very involved in the networking world. So an ISO file is kind of a weird thing that we call, we adopted that name ISO, or that extension ISO, to refer to a disk or a CD image in the form of a file. How many people have ever downloaded or know what I'm talking about when I say ISO? I used to just take it for granted that everybody knows what an ISO file is. but I know a lot of you don't. You don't know what ISO means. So an ISO file is typically a CD or a DVD image. It's one single file. It's like an archive. It's intended to be burned onto a CD or a DVD drive or disk, or put on a USB thumb drive and then physically put into a computer, booted off of, so that you can install an OS. What we do is in a virtual environment, which is what we have here, we simply just download that file, that one file, and we use it however we want to use it. I've already downloaded that a file. I downloaded a Windows 10 ISO, and then I uploaded it to the domain controller server, and I attached it to the virtual machine. And I'm not going to go through all of that, how I attached it to it, but I'll show you what I've done already. So I probably don't want to use this as a template. So what I did, I wanted to create Windows 10 virtual machines for you guys to use. So the first thing I did was I took a snapshot, or I made a clone, essentially what I did here. And this one's called template 0_template. I chose to call it that. Windows 764-copy. Now the reason I cloned it is because that's my original template and I don't want to screw it up. So if my Windows 10 upgrade fails, or I run into issues or roadblocks, I still have a template virtual machine to start with to go build your catalog of virtual machines from. So in this machine, here's what I did was I right-clicked on this, and this is true for most virtual environments, whether it's VMware or Hyper-V. There's some method typically to clone a virtual machine. So I simply clicked on clone, answered a couple of questions, and it made an exact copy of that machine. Only changes one thing, and it changes the data link layer address, which is what we're going to hopefully get to today, the MAC address. Changes that because, again, you can't have two, just like you can't have two domain names, can't have two MAC address names. So I cloned it, then I went into it after I started it, and I changed the computer name. So I called it, let's see what I called it. I'm pretty sure I'm remote viewing it right there. These are some remote viewing sessions, kind of like how I'm doing Chrome Remote Desktop, but I'm using the VMware viewer here. So here's the copy of the thing I'm viewing. So this looks a lot like it, but let's see what I've changed on here. So if I go to computer and I right click on computer, I go to properties, and I look, I see I've called it Win764-2. I just stuck a 2 on it. It is in the domain eilab.bauer.uh.edu, but what I did earlier after I cloned it was I removed it from the domain temporarily, made sure that I could access it locally. So I changed the local admin password just in case I had a problem with joining it to the domain. Then I re-added myself to the domain. Now the next step, let's pretend this is not a virtual machine. If you wanted to upgrade this machine from Windows 7 to Windows 10, you would open the little drive door on your DVD drive if you had a DVD player, stick in the Windows 10 DVD, or you would stick in the USB thumb drive. Well, this is a virtual machine. Beyond the borders of this window I'm looking at, this machine doesn't exist in the outside world. So the only way I can touch it and talk to it is within this virtual environment. So I've got a little menu set up here and some tools. One of the tools, fortunately, happens to be a CD attachment tool. This is really nice to be able to do this. Can't do this with all virtual environments, but this is pretty awesome. I need to put in a DVD drive. How do I do that? I've already put one in. So see how it says disconnect? I've already connected to it. I downloaded this Windows 10 ISO file. Can you see that? I know it's a little small. Downloaded that, and then I simply pointed to it with this piece of software, this application that's running the Windows viewer here, and said, that's my CD drive. So that file is my CD drive. So if I were to click on my folder icon here, and I clicked on computer, I should be able to see there's a CD drive, that ISO file. If I double click on that, it should start the startup program. And actually, before I do this, before I try to install Windows 10, I'm going to do one other thing that is really nice to do in a virtual environment is I'm going to take, not a backup, but I'm going to take a snapshot. Not sure if I did this already. So come back out here to the environment, right click on that. And let me go, I think I maybe already took a snapshot. So let me go to my snapshot manager. What a snapshot does is it allows you to go back in time. How many of you have ever done something on your computer or on your laptop, deleted a file, or done something and you realize, oh crap, I just effed up. I did not mean to do that. I sure wish I could go back 5 minutes in time and keep myself from doing that. Well, that's what snapshotting does. Snapshotting is awesome. Anybody ever used snapshots before? Or ever heard of that concept before? It's only available in virtual environments, but it's awesome. A lot of this stuff, it's awesome to me. Maybe it's not awesome to you guys, but I don't know, time travel is pretty freaking awesome. So I'm going to take a snapshot. Or actually, I already did. So about an hour ago, maybe an hour and a half ago now, before I came up here to school, I clicked on Take Snapshot. I called it Before Win 10. What does that imply to you? I'm about to install Windows 10. So what this does is it takes a copy. It basically sets a bookmark. It copies up everything in RAM. Now, it doesn't make an exact copy of everything on the hard drive. It just sets a bookmark in the virtual data. And then all the new stuff from now that I'm about to do is not really written to the hard drive. It's written to a separate little file, which later on will get reconciled into the hard drive image. But I set that little bookmark just in case I fucked up. Oh my God, I need to go back to that bookmark. You can take a snapshot and it can live for weeks or months or years if you wanted to. I don't recommend that it live for years, but I've seen people make snapshots and have snapshots and the ability to go back 6 months in the past, a year in the past, just in case they messed up. Now, once you roll back a snapshot, once you go back in time, you can't go forward in time. You can't go back to your original forward point. So that's one thing to remember about taking snapshots, but very, very powerful tool. We learn this and we make extensive use of it in 4397. Have I posted previous class lecture? No, I'm behind on that. The class lectures were on this laptop that I'm using right now, which I left at school, so I wasn't able to upload them. I promise I will upload them tonight. Last 2 classes plus this class right now. So took a snapshot already. Make sure I'm recording this. I think I'm recording. I want to make sure. I guess if I'm not recording, yeah. I'm pretty sure I am recording. So at this point, I'm okay with going ahead and trying to install Windows 10. You'll notice there's a little bit of lag with the mice there. That's just how that works. When you're remote viewing a computer that's remote viewing another computer that's remote viewing a third computer. I should not need a license key because I'm here at U of H and we have location licensing or volume licensing. Also, when you upgrade from Windows 7 to Windows 10, you don't need a new license number. You can use the old.
This person's saying that there's no freaking order on the thing.
Are you asking a question? Were you asking a question just now? Where do you see the recording, Saray? I didn't see it. Is it showing it on your screen and just not on what I'm looking here? Maybe it shows it on a different place. Sorry, I thought I turned off my volume. All right, so this might take a while, so I'm not going to sit here and install the Windows 10. We'll look at a couple of other things, but I'm not going to check that box. I don't want to help Microsoft or anybody do anything. Again, and I think I mentioned that in this class, whenever you're installing software, don't ever agree to any of those surveys or agree to help do anything, because what that does is installs a program in the background of your operating system and just slows your computer down, takes up space. It's basically spyware.
Professor, you're recording this class because we can see the red blink button. It means you're recording. And whenever I join the class, it says that this class is recording. So I think we are.
Okay.
It's on the left side at the top. There's a red button and it says recording.
Oh, I see it now. Yeah, I'm just not as familiar with Zoom as I should be, but thanks for pointing that out to me. So hopefully, I tried to do this earlier and I ran into some technical issues, like it caused the computer to leave the domain, and then I had to log into the computer as what's called a local user. And this is confusing to some people too. Once a computer joins a domain, you end up with two sets of users, at least on Windows. Applicable. I accept all your terms of endearment. Okay, so you end up with two sets of users, local users and domain users, or maybe more than two sets if your computer belongs to multiple domains. If you do have a laptop, for example, that you take from one place to another, you could be a member of multiple domains. This is some other stuff you need to be aware of. Using the standard tools in Windows that you find on the menus to view users is not as powerful. When is our test? Our test is going to be, I'm going to try to make it available by the end of this week, but I don't know if we can get through all this. Probably end up being next week. We don't have very much time here. I understand that some of this delay has been caused by me, some of it's been caused by COVID. So I'm taking that into consideration. So I know some of you feel a little bit lost here, a little bit behind. Don't worry, you're not behind. Yes, there is a review. And actually the review for exam 1 is posted for last semester online right now if you wanted to get a head start. So I'm going to click on start here. Let's see, not for that computer. I'm going to click on start for, might go a little slow, but I'll click on start for this machine. Nah, it's going to go too slow. Let me remote view or look at a different computer here. Give me 1 second. And look at this one here. This is another virtual machine that happens to be running in the lab. Installing operating systems or upgrading operating systems is very processor intensive, so everything will be super laggy, so I don't want to do that. Close that. I'm going to click on the start button, and I'm going to run something called computer management. And this works for Windows computers all the way through Windows 10, all the way back to Windows XP. Computer management. It bypasses the control panel, bypasses all of the menu-based stuff. I'm going to click on local users and groups. I'm going to click on users, and this will tell me the users that are built in, or the names of the local users. And what you don't see here is the domain user. I'm logged into this computer. If I click here, right-click here, go to properties. This computer, this JakeWin764 here, is part of this domain eilab.bauer.uh.edu. And I'm logged in as a user called Jake at eilab.bauer.uh.edu, but you do not see me in this local list. That's because these are local users. So one concept that confuses a lot of people, even people that use Windows a lot, is that you have local users on a computer, which are basically work group users, local only on that computer. Then you have domain users. Domain users don't show up in this list, but it's important to make sure that you've got at least one local user. And this is the only reason I'm showing you guys this. it's important to have at least one local user that's an administrator. There's usually a default user on Windows machines called administrator. Doesn't usually show up. You don't usually see it in a menu. You have to enable it. It's also a good idea to add a second one, like I've got one called EI Lab user, and then make him a member of the quote unquote administrators group. So I recommend that everybody do this to your computer, to your own Windows computer. If you have a Windows computer, or if you have one that maybe you're using from your company, do this, add a new user. Just gonna call it Jake here. Give myself a generic password here. Turn that off. Password never expires. Create. And the only reason I recommend you do this, because this will save you if you ever have domain joining issues. I'm going to right click it and I'm going to go back to properties. I'm going to say he's a member of a group called, you don't have to type in all of it, administrator, no, I guess you do, excuse me, administrators. You don't have to in the newer versions. So if this computer, I know this is a virtual machine, but if this was a real computer and I wasn't connected to a domain or my domain controller went down, I could at least log in as this user Jake that I just created and surf the net or do something on the computer. Highly recommend that you do that. Okay, so I'm going to go through the steps now. See if I can go. I'm going to go kind of quickly. I'm going to speed it up some because I'm bogging down a little bit. But I think this is interesting and important stuff that you guys need to know, even as business type managers, because there's a lot of potential here for abuse and misuse and not setting up things properly for effective management of users of your networks and your computer hardware, especially on computers that are shared, not necessarily computers that just one person is using, excuse me, but shared environments, which is what networking is all about, shared environments. My phone is blowing up today, sorry. Okay, so I need to go to, let's see, domain controller, virtual desktop, blah, 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 delete the snapshots, power the template back off. Okay, so I need to log into my domain controller, which is right here. Oh, excuse me, not the domain controller, back into vCenter here. Ready to install Windows 10, cool. I guess let's start that. That's that copy one. All right, we'll let that go, and hopefully that'll be done, a couple of hours from now. It'll take a while. So here's the thing I want to use as a template. It's on right now. I want to turn it off. There are a couple different ways to turn it off. I'm going to turn it off properly by actually going into the machine and doing an orderly shutdown. That's the best way to turn a machine off. You typically don't want to turn it off external in the outside virtual environment. You want to use the internal or the local shutdown procedures to properly shut down a virtual machine. A lot of network managers make the mistake of powering off a virtual machine, and if it does not shut down cleanly, we call that a clean shutdown, it may not boot back up properly. Has anybody ever lost power to a laptop or a computer they were using? Power went out or whatever, your battery died, and you go to turn it back on and it doesn't work properly anymore, doesn't boot anymore? It's because it did not, or it comes up with a blue screen. It goes, there's a problem with your computer. I don't know if that happens with Macs. Does that happen with Macs too? But it was not cleanly shut down. And I've had laptops where they were irrevocably damaged, not physically damaged, but I had to basically reinstall Windows. So we try to do a nice clean shutdown. Just talking a lot about best practices today. So that thing is off. Let me go to my notes here. So now I'm going to go to what's called, this is a new VM I haven't showed you yet, called the Zen Desktop Studio, which is what I use to, as I mentioned before, build a catalog of a bunch of virtual machines based on that template that I created. Zen Desktop Studio. Okay, let's see. They should all be gone. I don't know why they're still showing up here. Let's see if I can right click and make them go away real quick. These are all from last semester. I was busy deleting them earlier. Yeah, I didn't think so. None of, they're not. They were already deleted, so. Delete catalog. I don't want this catalog anymore. Okay, so the term catalog, in this case, it just refers to a grouping of virtual machines that was built based on a template of one other virtual machine. Works really well for student classes. So I'm going to right click on machines here. I'm going to create a catalog. What should I call it? Let's see, look at my notes here. The machine type, I'm going to say that they're dedicated machines, and that's because I want everybody to log into the same machine every time. A pool of machines would be like just you grab the next chair, you know, general admission to a movie theater, basically. Whereas dedicated is you've got a seat, you've got a specific computer you're going to use. Machine image. What's the master image I want to use? It goes and it looks at all the virtual machines that are available, and that's the one I want to use as an image. With that one, if the little plus sign, if there were snapshots, I could choose to actually image it from a snapshot as well. So I'll use the template Win764. I'm going to try. Again, I'll try to make a catalog later on out of Windows 10 machines if it works, but if not, we have these Windows 7 machines to fall back on. Number of VM numbers. This is basically the total number of machines I want to create. I've got approximately 55 students this semester, so I'm going to go ahead and create 60 virtual machines, just in case somebody screws up one and we didn't make you didn't make a snapshot. I'm going to use all of these defaults. So virtual CPUs, I'm going to give everybody 2 CPUs. That's just a relative number for speed. 4 gigs of RAM, that should be plenty. 80 gig of a virtual hard drive space, that's not a real hard drive space, and we're going to do what's called thin provisioning it, meaning your hard drive really is only about a gig to begin with until you actually start using it. Then it slowly fills up a file space. Create new computer accounts, not user accounts, but computer accounts. It's going to add computer names to the Windows domain controller for me. Okay. Domain is EI Lab, directory listing. I'm going to read through my notes here. Active Directory locations for computer accounts, I'm going to put them under virtual desktops. These are the groupings that were available earlier in the domain controller. Okay, the naming scheme. What do I want to name these computers? I'm going to name them Student VM dash pound pound. Okay, so it's going to start with Student VM 01 and just simply increment those up. The pound pound is like the wild card. I'm going to give myself a little description here. Administrator is permitted to use this catalog, keep the defaults. Just reading my notes, make sure there's nothing special I have to do. Let's see, what did I call the catalog name? I just call it Summer 2020. Catalog name, I'm just going to call it also the same thing, Student VM. Okay, so this is going to create 60 virtual computers for me. Pretty neat, huh? Takes a little while because it has to basically carve out all these virtual machines. So first, what it's doing is it takes a complete snapshot of the template that I used, just in case it's on, but it's not on. It takes a few minutes to do that. Then it's going to copy all those snapshot to 60 new files. That part's pretty quick. Actually, taking the snapshot's a little slow. Eventually, we will start seeing new machines pop up here in vCenter. We'll start seeing Student VM 1, 2, 3, 4, 5, 6, 7, 8, just starting to populate down the list here. So I'll keep an eye on that. So we'll come back to that maybe in a bit. I got to get ready pretty soon for the 4 o'clock class. So let's start getting into it. Again, the physical layer chapter is going to be a video that will be posted on YouTube. So let's look at data link layer. Okay, new desktop group. Okay, so yeah, that other stuff I'll have to do later. So here it's starting to create virtual machines there. See it here down here. So it's got a little, it's creating the snapshot here. That's going to take a little while. Then we'll start seeing some virtual machines built. Okay. Just leave that running in the background. That's the thing I love about virtual machines is it's like having several employees or several copies of yourself doing multiple things at one time. Yeah, your one computer, your one Windows environment can do multiple things, but it's better to have multiple computers doing different things in case something that you were doing on that one computer causes it to crash. You don't lose other jobs going on. Virtual environments are really good about keeping the Windows virtual machines separate from each other so they don't interfere and mess up each other. That's one really good reason why to use a virtual environment. It's like everybody's little own sandbox, and I can do anything in my sandbox, and I won't screw up your sandbox, and you're 6 feet away over there because, you know, it's COVID-19. Oh, by the way, somebody mentioned, so I'll go ahead and show it to you now. If you were to log into Blackboard now and go to the course content, you will see that there is, for those of you that are concerned, there's Exam 1 study notes right there. You can download them and begin studying them right now if you wanted to, or when Exam 1 does finally get posted and available. So although the dates are incorrect on some of the homework assignments because I haven't updated them yet, And there's not really any dates here as to when the exam will be. The content is there, okay? All right, so again, physical layer will do asynchronously. Data link layer, so that's layer 2. Microsoft, by the way, calls this the hardware layer, or they refer to it a lot as the physical layer because they're combining layer 1 and layer 2 together. They are definitely separate things. Layer 2, everything above physical layer is code. Okay, keep that in mind. Everything below the data link layer is hardware. Everything else is code. There's no hardware in data link or network or transport or application. There may be hardware involved, but each of those hardware items within a network has a layer 1 and a layer 2 and maybe a layer 3, 4, all the way to 5. Routers have up to layer 3, gateways have up to layer 4, and workstations have 1 through 5. They have everything in them. Did it download or did it go? Oh, there it is, excuse me. Okay, we'll see how far we get on this before I have to stop. It's 3:30 now. As you guys at 3:30, that's what I got. On my multiple screens here. Need more coffee. Okay, so data link layer. Sometimes we also call this the MAC layer, by the way, and that's what MAC address comes from, by the way. So as I mentioned before, data link layer is layer 2 in the internet model, above the physical layer. It controls the way that the messages are sent on the media. It interacts directly with the physical layer and the network layer. It's the go-between. It organizes the physical layer bit streams, the ones and zeros that are coming into the physical layer of that host, and going out of the physical layer, it takes the data, not the ones and zeros, it takes the letters, the A's and B's and C's, and all the stuff that we can read, helps to convert those into ones and zeros to put them into the physical layer. Organize the physical bit layer streams into coherent messages for the network layer. That's on the way up through it. Major functions of the data link layer, and this is why we need a data link layer, is to control the media. Now, we didn't talk about physical layer yet, but what is media? The media is any environment that a network signal travels through. Could be a cable, could be wireless, could be radio signals, could be infrared or ultraviolet light, fiber optic signals. So media is any environment that your network signal passes through. It's the stuff behind your computer or outside of your computer. Media access control. It's got to be controlled somehow. Just like a classroom environment is controlled. You can't have everybody talking at one time or you have chaos. Error control. The data link layer is responsible for detecting and controlling errors. I'm not talking about human error. I'm talking about errors caused by the environment. And then what's called message delineation, learning or figuring out when a message begins and ends. Everything in networking is laid out in serial bit by bit. Basically, a computer network is a one-lane or a two-lane highway. Think about it as a two-lane highway. There's data going in one direction, cars driving in one direction on one lane, and cars driving in the other direction on one lane. And there's not a multi-lane highway. So all those ones and zeros that are coming into and going out of your computer, they're all lining up one at a time. Or let one guy at a time through the door. Okay, so because of that, we have to have some way to indicate where the beginning and the ending is. Messages. Oh no. I'm going to do something with one of my clients. Got some internet outages, but one of my clients just texted me and said, yeah, we bought a new laptop a few weeks ago and dropped it on the tile floor and broke it. They want me to try to fix it. Cell phones can survive a drop. A lot of times laptops can. Anybody ever drop a laptop on a tile floor or concrete? That's one thing they haven't figured out how to build too well yet. So anyway, media access control. And again, the data link layer is many times called the MAC layer, M-A-C. Remember that, memorize that. Data link layer, data link layer 2 is many times called the MAC layer. Not the Big Mac layer, nothing to do with McDonald's, stands for media access control. And that's where the term MAC address comes from, by the way. I had asked you guys to do a little assignment where you looked up your MAC address or your hardware, a physical address of your computer. That was that 12-digit long number that looked like something like this, 00-0C-3B-B-2A, something like that. It's different on everybody's computer. That's a MAC address. 1-0C, just to fill that out. Or maybe it has colons in it. Colons or dashes is either way is okay to enumerate it. So it controls which device can transmit and when. It's important on a multi-point circuit, LANs or multi-point circuits. Think about a wireless network. That's a multi-point circuit. You can communicate with anything else in the area wirelessly because you don't control really where those radio waves go. If you had the appropriate software on your computer and somebody else had the appropriate software, you could literally set up a point-to-point network just between your two computers. You don't even need a wireless access point because you have a radio transmitter or transceiver in your computer. But because we're communicating in this medium of wireless, and we only have one highway road or one lane, only one computer at a time, even on a wireless network, at any one microsecond in time, there is only one stream of data going through the medium for one computer at a time. I know there's multiple channels on wireless, but let's pretend there's just one channel for just purposes of clarity. So because of that, we have to have a way to control that, and that's what the data link layer does. That's the hardest concept for people to understand about this layer. It has to control the media. You can also think about it kind of like a doorman at a club. Everybody lines up in order to get into the club because the doorman has to check everybody out and also let in only a certain amount of people. Your data link layer works like that doorman. He lets in only people he's verified meet the criteria, like they're allowed to be in the club, they're over 21. And he has to see them one at a time, one line at a time. He can't have 6 people trying to walk in the door at one time. He's going to say, hey, get in line. Let me check you out one at a time. There are 2 approaches to networking. There's the contention-based approach and the controlled approach. And the first type of networking was a controlled, orderly approach. That means everybody basically got in line. So let's skip contention-based for just a minute. I want to talk about the controlled approach, the original networking. In a controlled approach, each device must get permission first to transmit, just like in a classroom environment, in a normal classroom environment, not this one, but a normal classroom environment is you have a controller at the front of the classroom. It's, in this case, it would be me, the teacher. I'm talking most of the time. Or if you're taking a test, the proctor, or somebody controlling the room. If you want to ask a question, because it's a multi-user environment, and if you blurt out your question, everybody else in the room is going to hear it. You raise your hand. And I, as the controller, have to call on you and say, okay, I recognize you, and I will give you the floor right now. So only you have 100% use of the media or the medium. So you ask your question, and then I presumably give you an answer. Next person raises their hand, or if 10 people raise their hand at one time, I, as the controller, call on one person at a time. That's called access request controlled approach networking. That's basically how wireless networking works. When you want to send a signal, to the wireless access point on the ceiling, your computer raises its hand, says, hey, I've got some data to send. And the wireless access point says, okay, I'm busy with somebody else's transmission. Give me a second. Okay, I'm done. What do you want to say? Oh, you've got a frame of information. Good, I'll receive that frame. By the way, PDU, protocol data unit at this layer, is called a frame, not a packet, a frame. I'll receive your frame of data. Okay, looks good. Let me pass that on. Gets it from the next guy. So that's how wireless networking works. And roll call polling is an older form of networking where basically, essentially the same thing happens. It's a controlled instance, but rather than you raising your hand, I simply go around the room and I start with student 1A and say, do you have anything to say, yes or no? No, okay, I go to student 1B, row 1, student B. Do you have anything to say, yes or no? In other words, I'm calling roll. I'm checking every single user on a network. That proved on larger networks to be kind of slow, so we stopped doing it that way. And then there's another thing called hub polling, or token passing, token ring network, IBM token ring. And you can look up for historical purposes, and it probably does still exist in some parts of the world, even in some parts of this country, token ring networking. Not everything in the world is Ethernet. Everybody, you better all know what Ethernet is. Ethernet is the most common networking protocol, both wired and wireless. The 802.11 protocol is Ethernet. Token ring was the dominant network protocol, and before that it was ArcNet. I was a big ArcNet guy. These two are controlled approaches. Ethernet's a contention-based approach. ArcNet and Token Ring were both developed by organizations that required licensing. ArcNet was developed by DataPoint. Anybody ever heard of DataPoint? Probably not. Token Ring was developed by another company that some of you have heard of because they still exist, called IBM. Although we don't do a lot with IBM anymore because they don't make all the computers in the world anymore like they used to. They lost their competitive advantage. Ethernet, dominant network protocol. It was developed as an open protocol, meaning anybody in the world, any hardware manufacturer, any programmer, anybody that wanted to create code or hardware that used Ethernet protocol to communicate on a network could, for free, as long as they adhered to certain rules and standards, or maybe there was a small yearly fee that you paid, but it was a nominal fee. We're talking a few bucks a year versus several $1,000s a year. Ethernet was also developed by 3 organizations. Does anybody happen to know what 3 organizations invented the most popular networking protocols in the world? DEC is one of them. Digital Equipment Corporation. They were big. Some of you, or most of you, probably never heard of DEC, but they're still around. Intel. Anybody ever heard of Intel? Yes, you've heard of Intel or not? Intel makes most of the chips in most computers. There's only 2 chip manufacturers in the whole world, or chip developers, I should say, Intel and AMD. And then another company, which I know a lot of you have heard of, called Xerox. What is Xerox's claim to fame? What did they invent, basically? Or what, they didn't invent it, but the guy that invented it went to Xerox and said, hey, I've got this thing you might want to sell. Copiers, right? They invented, or they are the father of copiers. Interestingly, the guy that invented the copier, or the group that invented the copier, first went to IBM, because IBM was the dominant player. They were 99.9% of the market back in the 60s, and IBM turned them down. They said, man, this doesn't look like it's a useful tool, but we only think we could sell about 50 of these a year. We don't think these are, because back then a copier was $50,000, and it took like 1 minute to copy 1 page. He said, I don't think we don't think this is going to be a big deal. So they shopped it around, found this small company called Xerox, and they're like, oh yeah, that sounds like yeah, that's got a future. We'll hitch our wagon to you guys, and look what happens. So these days, Xerox, that company, is synonymous with copiers, although they do a whole lot of other stuff. In fact, a lot of people in an office, we all still have copiers, multifunction machines, but If you say, hey, can you go Xerox that? You don't use the word copy. Can you go copy that? What do you mean copy? You know, Xerox it. It would be kind of interesting if we were IBMing things. So Ethernet was invented by a bunch of dicks. I know that sounds kind of crude, but DEC, Intel, and Xerox invented Ethernet. I like to make that funny joke. Networking, modern networking was invented by dicks. Contention-based, this is what Ethernet is using, wired Ethernet, and actually Wi-Fi uses this to some degree as well, in a contention-based environment. And you'll learn why this works better. How are we doing on time? We're okay on time. I'm gonna go right up till 4 o'clock, by the way, okay? Actually, let's check and see how our virtual machining is going. Rest real quick. I lost. Oh no, there it is. Connectivity. How's our virtual machining going? Zen Studio. Might be done. And then the hard part's left up to me. Adding your usernames and some random passwords. Oh yeah, see there they all are.
So don't use the password that's on the PDF.
Well, maybe. I think what I'm going to do for starting this semester, this is probably a more appropriate thing to do. Come up with a random password that I email you guys, or something that's made up of your student ID and some initials, or something that says a little more than just a generic password. So yeah, those are 60 computers that just got built. Didn't actually take that much time at all. Not quite ready for you to use. I could turn them on and I could start using them and log in as me, but you guys don't have a username and password yet. And again, I want to see if I can get that Windows 7 machine fully upgraded to Windows 10. See, now I'm at the control. It's done its first reboot. So anyway, let's go back to this. Contention-based approach. This is where your computer transmits, your data link layer of your computer transmits whenever the circuit is available and there is no centralized controller. This is common in Ethernet. This was the whole premise behind Ethernet. They said, hey, that controlled approach works fine on a large network. Excuse me. Well, it works fine on any networks, but it adds overhead to have a controller. It requires an extra device on the network. And also, in the case of token ring, you'd have a controller and somebody calling roll, basically. So the way contention-based Ethernet works is devices are all polite. So in a small environment, let's say you're in a group of 5 people, not a classroom environment. You're in a group of friends, 5 people. How do you guys generally communicate with each other? Do you raise your hand and so then the other 4 recognize, hey, there's a hand raised? No, usually just one person starts talking. Hey, I've got an idea. Let's go to Mod Pizza and get some pizza or whatever it is you're doing. That works fine in a small group of 5 people. You don't need somebody to be the leader of the group or make all the suggestions. And if you and one other person in your group do start talking at the same time, what do you do? Yeah, stop. Who is that?
Sorry, I'm talking to my dog.
It was either dog or small child. And I was going to say, you're really mean to your small kid. Anyway, so in a small environment, we're polite, or our computers are polite to each other. In a small group, if 2 or more of you start talking at the same time, one of you goes, oops, I'm sorry, I didn't mean to talk over you. Why don't you speak? So in a contention-based Ethernet network, your computer does the same thing. It blurts out, it first listens in the media, whether it's wireless or wired. I don't see any bits going through the network right now. I'm going to go ahead and blurt my bits out there. And then it's going to listen and see where the bits received by the next physical device I'm attached to. If they weren't, I'm going to assume that there was a collision or something happened. Oop, I guess I must have talked over somebody. Let me wait a random amount of time and we're talking about microseconds here, picoseconds, and re-blurt out my frame of information or retransmit it, all those ones and zeros. If I get a response back from the device I'm physically, the next physical device I'm connected to, saying, yep, I got, those 23 ones and zeros, I got them, everything's good, then you blurt out your next message. That's how contention-based works. Shift F5, sorry. Now, in practice, and so the main reason why you've never heard of ArcNet and Ethernet, ArcNet and Token Ring is not just because Ethernet was free for anybody to develop, but because it is more efficient, because most LANs, most networks are pretty small, 5 to 10 devices. Usually on large LANs, if you're working in an organization that has lots and lots of employees and lots of computers, all those big networks are split up into little LANs anyway, because you're in functional groups. That's how most LANs are designed, in functional groups. One particular department, the engineering department is on a separate LAN, or floor 2 is on a separate LAN, or the finance people are on a separate LAN, and then our LANs are connected together on a backbone network. If you're in a small functional group, you're probably more likely to be sharing a network printer or sending messages more internally to each other. So most LANs are not big. So that's why contention-based approaches work well. Somewhere, and this is just a sample graph, the crossover point generally is around 20 nodes or 20 hosts on a LAN. With a controlled access approach, it is more efficient when you get to have like 50 or 100 computers on a LAN, whereas a contention-based approach does not work very well with more than 20. Imagine being in a room of 20 people, and I know this has happened to you. You guys are in a room of 20 people. What's the chances of, and let's say you're at a party, what's the chances of 2 or more people talking at one time in a room of 20 people? It's much greater than if it's a room of 3 people. Now, what do you typically do? Anybody been to a party lately? Probably not, but you remember what parties are, right? Where we actually get together and face-to-face people. So when you go to a party, what do you typically see at parties? And I'm not asking you to describe your parties. I'm just saying, what behavior do you typically see at parties?
Laughing.
Well, what social behavior, what communication behavior do you see at a party? Is there like one guy doing all the talking and everybody's listening to him? No, that's like a classroom. People break up into little groups of 2 or more. That's what I'm trying to get at. So in a large party environment, we all break up into little LANs of 2 or 3 or 4, and we have a little communication with each other. As soon as you're done with that boring conversation or whatever, or you find that they're talking about stuff I don't have any interest in, you walk over to another LAN or another group of people and you start talking to them. Hey, I'm Jake, I belong to such and such club. Let's talk. That's kind of like what LANs are. So contention-based wins because of that. Error control. Let's talk about error control. I'm going to try to figure out the best place to stop here. Let's see. Actually, okay, so I'll stop here. So error control. Network errors are going to occur even on a small network, even on a network of 2 computers, of two nodes on a network, because again, they don't ask permission to talk. They just listen and they blurt their message out. So network errors occur because of what's called collisions. In fact, the official name for Ethernet networking, and you probably should know this, the official term is the official mnemonic. You guys know what a mnemonic is? A mnemonic, not demonic. Carrier sense multiple access with collision detection and or collision avoidance. That is the true name or the true mnemonic for Ethernet networking. Carrier sense multiple access with collision detection and avoidance. That's a mouthful, right? So we just say Ethernet. Where does that term come from? Ethernet, by the way. Made up term. You guys can go Google that on your own, but you probably should Google that just so you have a clue as to where the word ether. We can probably guess where the word net comes from, network, but where does ether come from? Go Google that. It's an interesting little story on where that term ether came from with respect to Ethernet. So errors occur because of collisions or other things going on in the media that we're using, especially in wireless media. Data can become corrupted. Ones and zeros can turn into zeros or ones. Data can be lost, just like in a conversation between you and me, and especially like in a party. I'm trying to talk and have a conversation with you, but there's some loud drunk asshole in the corner making a bunch of noise. He's interfering with our communication. He's noise. That happens on networks as well, especially in wireless networks. Lots of noise in wireless networks, and that's because there's a lot of wireless stuff going on. A lot of radio frequencies floating around in the air. Some are man-made, and a lot of them are natural. You know, we don't make all the wireless waves in the world. The sun is probably the most dangerous thing that we know of when people talk about radiation and radio waves frying our brains and everything. Well, the sun, which is 93 million miles away, is generating a hell of a lot of radiation. If we did not have the, and I don't mean to get all artsy, not artsy, what's the term? All sciencey here, all science guy here, but it's interesting stuff. If our core of our Earth was not made of, it was not basically a giant magnet, a giant lead magnet with the magma flowing around it, we're basically a big magnet. If we did not have a magnetic field around the Earth, the radiation from the sun would cook the Earth and nothing would be alive on the Earth. Anyway, networks need to be designed with error prevention, error detection, and error correction, which we'll talk about that in the next class, but I want to point out this chart. This is an important chart for you guys to memorize, hint, hint for the test, and know what these things are. White noise. What causes white noise? What is white noise, first of all? Can anybody tell me real quick what white noise is? And don't get racial on me. White noise is noise that's occurring in the environment, that's just there. Like when you're talking and having a conversation out on the street, there's other stuff going on. If you stop talking for a moment, you'll hear birds tweeting, cars driving by, the wind, trees rustling. And it affects your conversation a little bit. If it gets windier or the traffic gets noisier, you simply start talking louder. In other words, you increase your signal strength. Impulse noise, that's a sudden increase in an outside signal, such as lightning, or somebody turning on a drill, or some other radio frequency generating device, which causes a quick burst of energy or quick interference of radio waves. Lightning is the best example of that. Impulse noise in a real world environment would be like you're having a conversation and then you hear a loud crash in the background because somebody dropped something. It might interrupt your communication for a few seconds, but then you continue on. So we shield or move the wires. If you want impulse noise to be prevented from affecting your networking communication, you move indoors where it's quieter, or you move to a quieter place. When you're talking crosstalk, that's where you've got one physical media path. This usually refers to a physical wire. One physical media path, but you hear other signals. How many people, by the way, and this is true for other reasons, how many people have ever been on a telephone conversation and you can hear another quieter conversation going on in the background? It doesn't happen so much anymore, but it used to, particularly on international calls or calls that are happening overseas. You hear very quietly another conversation going on because the signals are too close to each other. Echo, this is poor or misaligned connections, tuning the equipment. That one's less, I can't think of any good real world examples for that. Attenuation, this is a gradual decrease in signal over distance. A real world example of that would be you and a friend are talking to each other and you're having an easy conversation, start walking away from each other, face each other, and start walking backwards away from each other. At some point, you won't be able to hear each other over the white noise that's occurring in the environment unless you either talk louder or you use repeaters. In other words, you put a person between you and that other person. And you say, hey, pass this message on. We're too far apart. We can't move, but you can. So here, I'll tell you my message. You go walk over there and tell him what I said. Attenuation, weakening of a signal over distance. It's very obvious on wireless networking. You can physically see it happen if you use Wi-Fi analyzer, or if you're on your cell phone and you're driving out in the country and you drive away from a tower, you'll see your cell phone bars go down. So you use repeaters or put in more cell phone towers. Intermodulation noise, this is signals from several circuits combining to create a third signal. The best example of this I can give you is like harmony. You guys know what harmony is? When two people sing together, why does harmony sound better to the human ear? When two people or even three people are singing together with two different notes at the same time. It sounds better because it's creating a third sound. They overlap with each other and create a third pleasurable sound. Harmony is neat. How many people have ever hummed along to a motor? I used to do this when I was younger. Vacuum cleaner, running the vacuum cleaner, and the vacuum cleaner hums at a certain harmonic level, hums at a certain level, and you can hum along with it. And at some point you can reach the harmonic level of your vacuum cleaner. So, you can find it. You can hum along with your vacuum cleaner. And then if you modulate your tone, in other words, go down with it a little bit or up with it a little bit, you start getting these weird sounds in your ears, like this vibrating sounds. It's called intermodulation noise. So next time you go to vacuum your carpet, if you have carpets in your house or if you have a vacuum, turn your vacuum cleaner on. See if you can hum with your vacuum cleaner, and then tell your roommate, you know, you're doing this as an experiment. You've got a crazy networking teacher, so they don't think you're insane. Hum with your vacuum cleaner. See if you can create an intermodulated noise, which networking equipment doesn't like. It doesn't like that third signal coming out of nowhere, or that second signal coming out of nowhere. It generates extra ones and zeros. Okay, so I'm going to stop the class there. I'm going to finish most likely by tonight setting up those catalogs. And like I said earlier, I'd like to be able to offer you Windows 10 machines so that you can start working on Wireshark, which we've not really talked about yet. So I've got to get that finished. I'm going to start my 4397 class now. I'll post this and the previous two classes. We missed one class. It was asynchronous, the physical class. I'll post that and the previous class on YouTube just as soon as I can, hopefully tonight. And the due dates, yeah, I'll put official dates in there, but right now, don't stress it, okay? I'm being realistic. I'm not going to tell you, okay, everything's due tomorrow or everything's due this weekend when I haven't changed any of the dates yet. So don't stress too much about dates. We'll get enough stuff done to where you guys you'll be learning some stuff, okay? Hopefully you are all being good about following my notes here when I type in these notes, and you're Googling for these things outside of class, which is what you should be doing to learn this stuff, okay? So make sure you're looking that stuff up. I'll see you guys on tomorrow. Same bat time, same bat channel. Go Cougs.